Hello, everyone. Thank you for joining us today. We are on the April session for the APAC Scientific Forum. Today, we're going to be going into Singapore's efforts towards the OMOP genotyping efforts. Before we go into that, Song will be giving us a high-level update in terms of the OHDSI OMOP events happening in APAC. Over to Song. Thanks.
Thanks, Mukesh. So I also highlighted this in the March community call, right? So there were some discussions since last year about doing a lot of in-person events this year. So hopefully to train people, get new people interested, etc. and etc. So in efforts of those, as a fruition of those efforts, there are actually 2 events happening in April, which I'm going to highlight briefly at today's call, and then I'll hand over to Erwin so that he can get started. So the first event is happening in Japan. It's taking place a little over a week now, right? So April 17th in Tokyo. This event is hosted by our OHDSI Japan colleagues. We will have a half-day event, right? So as you can see from the agenda was previously tentative. Now it's finalized. I'm not gonna say final because sometimes I need to always keep room for some adjustments at the last minute. But majority of the agenda has been finalized, where we'll have both the OHDSI Japan collaborators talk about things happening in Japan, as well as Mui to talk a bit about OHDSI APAC, followed by Danny, a special guest. So Danny's in Japan. He will be attending this event to give a speech around why federated network studies in a country, specifically in his experience doing the OHDSI UK Study-a-thon recently. And then after that, we'll have Chan do a hands-on session around replicating a existing, previously done OHDSI network study called Association of Ticagrelol versus Clopidogrel with net adverse clinical events in patients with acute coronary syndrome undergoing percutaneous coronary intervention. I sound so smart when I say this. But yeah, it's a great study that was published several years ago. We're gonna try and familiarize the Japanese collaborators around how to use the OHDSI methodology as well as OHDSI tools. So the registrations are now open. It's at the link down here. I'll also post this in the chat for people to check it out while Erwin gives his presentation as well. And moving on to the next event, right? The next one is going to be hosted in Thailand. It's 1 week after the event in Japan. This is hosted by one OHDSI collaborator in Thailand. I'm not saying the OHDSI Thailand on purpose, deliberately, because OHDSI Thailand is not an official chapter yet. So we do have a collaborator in Thailand that has put in some OHDSI/OMOP efforts and getting that into his organization. And this event will be hosted by IQVIA and that organization, which is part of the Siraj Hospital in Thailand. So similar to the Japan event, we'll have a mix of lectures as well as a introductory tutorial, but this one is different from the Japan event that it's a full day event. So we'll start off the event with a global perspective on Mui and Sarah speaking about some things happening both global as well as in the European areas, followed by a OMOP OHDSI kickoff introduction. And then we'll have some local folks talk about their experience and their perspectives around real world data as well as OMOP/OHDSI. And then after lunch, we'll have the introductory tutorial around the OMOP common data model and its vocabularies, as well as the ETL process, right? And on top of this, we'll be adding a few minutes for exercises so that the audience can get some hands-on experience as well as apply their learnings, not just hear us talk one way, right? So the registrations are also open for this. I'll also post the URL in the chat as Erwin kicks off his speech, his talk. Is there any questions from the audience with regards to the events? Otherwise, I'll hand over to Erwin so that he can get started with his presentation. All right. Silence is good in APAC. So over to you, Erwin. I'll stop sharing.
Okay, thanks, Song. Let me just share my slides. Can you see my slides?
Yes.
Yes, we can.
Okay. Hello everybody. So my name is Erwin, and I'm working under Mukesh in the data management team, Bioinformatics Institute of A*STAR. Today I would like to share with you on the Singapore's effort, right, to capture the genotyping data in the OMOP CDM. So for that purpose, we will actually use the a case study of a gestational diabetes mellitus cohort. It's a simplified cohort as a proof of concept. So in these presentations, right, I'm going to share with you the challenges that we have encountered during this exercise. Then subsequently, I will also share with you on how we go through it, we go around, we go about it, and then subsequently, we are going to show you on how we actually load it into Atlas, and then show you some of the basic analysis in Atlas, especially the cohort characterizations. So I try not to go too much into the details, but I will just give you a very big picture on how it is being done. Yeah. So in the during the presentation, if you have any questions, you can just stop me and then ask questions. So before that, I will just give a brief introduction, a brief overview of the cohort that we are going to use. So this is a gastro-birth cohort, which is actually it's a major collaborative research effort involving partners across the Singapore from the healthcare and research alike institute like the NUS, KKH, and A*STAR SICS. So the purpose of this gastro cohort study is actually to understand how the conditions in pregnancy and early childhood influence the subsequent health and development of the women and the children. So in this cohort, right, actually there are women data as well as the children data. But for this proof of concept, we are going to focus only on the woman's genotype, only on the mothers, on the mother's side. So this cohort is a longitudinal data. It contains a multimodality data, which includes not only the demographics informations, but it also contains the mother's health, the children's health, the psychological information, the clinical information. You also have the paternal informations, and then we have the imaging and the omics data as well. So the omics data, it contains the genomics, the transcriptomics, lipidomes, epigenome, proteomes, and microbiome. But for today, we are going to focus only on the genome, because for the other types of omics data, that will be the future work. If you want to know more about the gastro-birth cohort, you can go to gastrodataVault.sg, as shown in the URL here. So for the proof of concept of genotyping data capture, we are going to take the gastro strategic data set, which is related to the gestational diabetes mellitus, and it was scoped for this exercise. Instead of using a lot of clinical information at the moment as a proof of concept, we just take the simplified version of the data set, which only contains two clinical measurements, which is the glucose information as well as the fasting glucose measurement, and with the condition occurrence of the gestational diabetes mellitus. So for this clinical data, there are 1,176 subjects. Concurrently, we have the genotyping data, which is actually from the Illumina Human Omni Express Exome Genotyping Array, which contains more than 900,000 markers. And there are 1,079 subjects with the genotype data. But just for your information, for the genetic data, right, it's not only the only from Human Omni Express. We also have the whole genome sequencing as well as the other array as well, which will capture different type of genetic data. So the total overlap between these two, the clinical data and the genotype data, is around 1,035 subjects, which will be the data that we will be used in this proof of concept exercise. So just to give you an overview, a glance of how the genotyping data looks like. So here, the first table is actually telling you what are the markers in the array, and what is the chromosome position and the reference and the alternative allele for each of the markers. Then the genotype data is represented at the second table here, where it is actually represented in the SNPs or the markers is represented in the rows, and the samples are in the columns. So the genotype data is represented as like a reference or reference alternative or alternative. Yeah. So in the OMOP Odyssey tools, right? So there's this tool called as a Cohort. I'm not sure whether any one of you have used it before, but this is the tool that is developed by Odysseus Data Services Incorporations, which is actually used to identify the concept ID or the standard concept ID, right, from the OMOP genomic vocabulary. The input has to be from the VCF file, but we can actually modify it to actually take the HGVS notations, and then it will map to the OMOP genomic concepts from the antenna. So this is a very brief workflow for on how to use Cohort to take the VCF file, which is the markers informations, and then we map them to the standard concept ID. Okay, and this is actually the scripts, the R scripts, right, that I extracted from the Cohort's GitHub page. If you want to know more, you can actually go to this URL to look into it and play around with it. So, excuse me. So, as a general overview, right, when we want to map the genotype data to the OMOP genomic vocabulary, this is the standard workflow, where you take the VCF file and then you use Cohort to actually map to the OMOP genomic concept data, and then you will have the map data as well as the unmapped list. Okay, so from the more than 900,000 markers, we have around 1,175 variants that can actually map to the standard concept ID. Okay, and then from here, then you can take in the genotype data as well as the marker informations together with the map data. Then you can design a ETL script and then load it into the OMOP CDM database.
Orin,
However,
can I insert?
yes.
Can I ask a question? So you have then about 9,000 variants, and then among
900,000.
900,000, and then among the 900,000,
Yes.
900,000, 1,000 variants are mapped.
Yes.
Right. So most of them are not mapped.
Okay. So as you know that the Illumina array, it actually it will genotype all the they have the design to type the known variations. In this case, right, then it will be for the, I think in the exome array, in the exome space, as well as some in the, they have their own design based on the known variants. But then in the OMOP genomic vocabulary, right, you as far as I understand, they will only include those that are clinically relevant variants. So there are certain public database that they actually capture only those non-clinically relevant variants, and then they load it into the database. Yeah.
Yeah. So to my understanding, the current OMOP genomic vocabulary only contains the variants which has been proven to have some clinical relevance or clinical significance, and most of the variants are actually does not have any proven significance. So, that's why only among the 800,000, only some of them are mapped to the current vocabulary. Okay.
Yes, correct.
Thanks.
Yes, correct. So that's why our focus, right, is then only on the clinical relevant variants. Yeah. But then from here, right, then in the Singapore context, right, when we discuss with collaborators, with colleagues across different institutes, then we understand that there are two challenges that we will face when we go through this workflow. The first challenges that we have is actually the variant ID representations, because not all the research labs, they will give you the like in a very in the format that you want. For example, in the like chromosome positions or the reference allele, alternative allele, all those kind of format. But different labs, they may have a different ID representations that, for example, some of them they use a DB-SNP ID, some of them will use the HGBS notations, some even will have the transcript annotations, or some will actually follow the variant representation schema notation, which is in a JSON file. So that's the first challenge. So we think of how we can actually simplify this effort so that we can actually take in the different ID representations, and subsequently we can actually convert it into the format, right, that can be taken by the Cohort tools here, because Cohort is a very useful tools for us to map to the OMOP genomic vocabulary. So the second challenges is actually the vocabulary that we have here, which is the OMOP genomics vocabulary. Because this is designed based on the OMOP community. So in the Singapore context, probably we have a local variance, especially in the population of interest, that might not be available in the OMOP genomic vocabulary. And how can we incorporate this into the workflow so that we can analyze these local variants, right, in the Singapore context as well? So to solve these challenges, right, then we actually introducing two subsections. The first one is actually we develop a tools which actually will standardize the different variant ID into a HGBS notations. Okay, and then subsequently we can leverage on Cohort to take input in the HGBS notations, in addition to the VCF file. If you have the VCF file direct, then you can use VCF file to run Cohort on that. Then the second challenge for the genomic vocabulary, then we are going to establish a workflow on how to add the non-standard genomic vocabulary. And this non-standard genomic vocabulary, we will design such that it will actually follow the structure of the OMOP genomic vocabulary. And then we can again use Cohort to actually do the mapping to the non-standard genomic vocabulary. So how are we going to find to look for this non-standard genomic vocabulary? Then we are going to use other public clinical relevant variants database, or probably from our own. Yeah. So going back to the Cohort workflow, okay. So if you notice from here, the first two box here is actually if you take the input as a VCF file, okay. Then with a slight modification, we can actually start from the HGBS notations, and then we can merge and then get the HGBS notation with the concept ID. Okay, so this will actually be used for the mapping to the non-standard genomic vocabulary. So we just do a slight modifications. Okay, so we go back to the original workflow. So the first step will be, we will have a standardization step where the input data, right, can be in the VRS JSON file. It can be in a text format, based on the variant ID or HGBS notations, or whatever ID that can be used here, or in the VCF file. Then we do a standardizations, where the standardization we actually convert it to the HGBS notations. Okay, and this standardization, right, we will leverage on the ClinGen genome resource database. Okay, because from there, then we can get, we can know this ID is actually what is the HGBS notations. Then from here, we map to the, we use Cohort to map to the standard concept ID. Then subsequently, the unmapped one, we will also output it in the HGBS notations. And then again, we use the Cohort to reference on it. We leverage on Cohort to map to the non-standard genomic vocabulary. So again, we have an additional of 916 variants mapped to the non-standard vocabulary, and then we design the ETL to map to the OMOP CDM database. Okay, so this is basically the general workflow that we will use to map the genotype data to the OMOP genomic vocabulary as well as the non-standard genomic vocabulary. So how are we going, how do we establish the additional non-standard genomic vocabulary? So at the moment, we actually take it from the ClinGen ClinGen public resource, and we downloaded two lists, right, based on the gene disease validity and the variant pathogenicity. So from here, we get around 22,000 canonical allele identifier. And then from here, we try to exclude those that have already been reported in the OMOP genomic. So you can see that they do not actually they do not overlap a lot. Okay, so after that, then we can see that the unique number of the additional non-standard genomic vocabulary, right, is around 22,324 IDs. Okay, but then we notice that there are 11 of them is actually a copy number variance. Then we exclude them from the non-standard genomic vocabulary, and we have 22,313 IDs to be added to the non-standard genomic vocabulary. So how are we going to generate the non-standard genomic vocabulary from here? Okay, so the variance, if you have the variance already in the canonical identifier, canonical allele identifier, then you can start from here, and then you downloaded the JSON file, and then you extracted the information like the HCVS notation for the genome and the transcript and the DB-SNP and other informations. Then you can use this to generate your concept and the concept synonym table. But if your non-standard genomic vocabulary, let's say that there's no canonical ID here, then you can use the notation like this, in the my variant info notation. So you tell them the chromosome is a genomic positions. What is the reference to the allele, to the alternative allele, and then we based on the ClinGen to get the canonical identifier. So this is how we generate the concept and the concept synonym table, and this will be loaded into the OMOP CDM database as an additional non-standard genomic vocabulary. Okay, so from there, right, then we design the ETL, and then we the ETL scripts to load them into the OMOP CDM, and this is just a snapshot or a snippet of the first two rows, right, and then I transpose them to tell you how the data being stored in the measurement table. Okay, so you have the measurement ID. So this measurement ID is actually an auto-generated one. Then the person ID, okay, and then the measurement concept ID. So I purposely highlighted here because this is the standard concept ID from the OMOP genomic vocabulary, and the right one is actually the non-standard genomic vocabulary from our list. The measurement date. And then another thing is that for the measurement type concept ID, at the moment we use the lab as the standard concept. Okay, probably if next time if there is a concept type, right? Like for example, whether it's a array-based genotyping array or whole exome sequencing or whole genome sequencing, then probably this will be updated. Then we also keep the original genotype informations like 1 and 2. So 1 is basically a heterozygous genotypes, which contains of the reference and the alternative allele, and 2 is actually the homozygous for the alternative allele. Then you will notice, right, that why there is no 1, there's no 0. 0 is actually for homozygous reference allele. But for this, based on this design, right, we only capture the subjects with the genotype that contains the alternative allele. So if it's a homozygous reference allele, it will not be captured. Yeah. Then the value as concept ID, then we use from the domain measurement value. And then the class is qualifier value, and then the vocabulary from SNOMED, which represents 1 and 2 respectively here. Yeah, then the value source value, we keep the original genotype data, which is AG and TC here. So
Sorry.
now,
Sorry, once again, I have some questions. So I think if you capture the source, what is that? Measurement source value as like in your original data, there is some RSID or somewhere something else, ID something else.
oh,
You can capture that, and then because currently you are using the non-standard your custom vocabulary in the custom concept ID column, so it is not easily replicated in the next step, because you can change your custom concept IDs.
yes.
So
yes.
I think you can capture the original values in the measurement source value, and then
Yes.
at the source value source value. I'm not sure, but you may capture the location of the variance, not only the
Yeah. Thanks very much. Thanks for the suggestion. I think the capture the ID, the variant ID in the measurement source value is actually it's a very good idea. Yeah, I missed this one. Yeah, so thank you very much for the suggestion. Yeah. Any other comment? Okay, so I will continue. So for the study design in Atlas, okay, so we load in them into the OMOP CTM, and then we install Atlas, and then to see how we can actually have a visualizations of the data. So we built the concept sets for the gestational diabetes mellitus this concept set will be used as the criteria to include the cohort with the GDM. And then we also create another concept set, which is randomly picked up, right, such that all the subjects, right, has the genotype for this one, because this is just as a proxy to include the cohort with the genotype measurement. Yeah, then for the cohort definition, we created two cohort. One is cohort with the GDM, and the other one is the cohort with without the GDM, with the cohort entry and inclusion criteria as shown here. And finally, we do a cohort characterizations of the two different cohorts, and then we analyze the features according to the age group, the race, and the measurement value, as well as the measurement type. So this is the overview of the Gusto cohort. So I just take a screenshot of some of the important informations here, like the age and the first observations when they have the GDM. Then a tree map of the Gusto, the measurement report. So you can see there are quite a number of them with a genotype informations, and this is the race pie chart. So this is the criteria for the cohort with GDM and cohort without GDM. So the entry events as well as the inclusion criteria. So for the cohort with GDM, the entry events is that they have to have a GDM. Then it needs to have the genotype measurement as well. And then we use the proxy concept set to get that. And then for the without GDM, we use a genotype measurement as the proxy to let them entry the cohort, and the inclusion criteria is that no condition occurrence of the GDM. So the summary statistic is as well shown here. And then finally, this is the cohort characterization results. So we have the comparison across the race concept ID. Then we have the comparison across the age group as shown here. So we can see what are the, like for example, the risk of at the different age group, or the risk that is correlated to the race information.
Alright, but could you share the previous slide, showing the inclusion criteria of both of them? Because total events are different from the matched, so it means that there is some replicated persons in this cohort, in my understanding. So
Replicated one?
I think that the total events is 227, while the matched number was 193. So I think there is some replicated events, and it is reasonable since there should be the multiple pregnancies among these patients. But because the cohort entry events are different between these two cohorts, I'm not sure that it can be there is someone who have the multiple condition occurrences of gestational diabetes without multiple pregnancy during a single pregnancy events. So you need to think about that. Yeah.
Okay.
Chan, isn't this the earliest event? So like only 193 people out of the 227 people have a measurement of that PDGFRA. So I don't think it's events here. I think it's patient counts, right? Yeah, because they're
yeah,
using earliest events per person.
yeah, it's earliest events. Yeah. So yeah, I think Song is right, but because I just consider that because you are using the different entry events for.
I agree. It's not
two different-
directly comparable, right? Yeah, I think that's what Chen is trying to say. Yeah.
it-
So
Mm.
if you change it, you might get a better comparable of insight around the patient counts. But for now, I think what you're looking at is patient counts, not events. So I think, other than that, maybe changing the entry events and seeing how the results look different might be a better comparable analysis. But yeah, sorry to jump in. I just had to confirm that my understanding was correct there around the patient count.
Thanks, Song. Yeah. Okay, that's something that I will think about. Thank you, Chan. Yeah, so finally, this is the comparison across the measurement based on the two cohort that we generated. So and finally will be the genotype information. So I only extracted the 3 of them, and the rest of them is actually being shown as the XY plot here, where it actually tells you how many percent in the cohort with GDM and how many percent in the cohort without the GDM. Yeah, so finally, this will be our future work. We will expand this mapping to the whole genome sequencing data and other genotyping array data. Then since we also have other omics data, then we will start working on how we can actually include the other omics informations, like probably we'll start from the transcriptomics data, then epigenomics data, and then the proteomics data. So we anticipate that some methodological development will take place in this future work. Yeah, so I would like to acknowledge all the people here where directly or indirectly has been involved in the discussions. Okay, mainly from the NUHS and the MOH, the Gusto team, the Precise team, and then from the OHDSI team, where we have the initial discussion on how we can generate the non-standard genomic vocabulary. Okay, so that's all for my presentations. Thanks for your attention.
Yeah, I think this is really great demonstration of how OHDSI genomic vocabulary are used for the real clinical use case, and especially for these really valuable data set. That is really wonderful. Thanks.
Thank you.
Erwin, I also have a question. If you go back to the slide where Chan was commenting about putting in a non-standard concept in the concept ID field, the one with the red one.
Yeah.
Yeah. So, I might be wrong here. Chan, you can help me here as well. But so if we want to add in a concept that is currently not supported by the OHDSI vocabularies, I think there's 2 approaches, right? One is to map to the concept ID 0, which is no matching concept, and we add in the source value somewhere, right? I'm pretty sure there's one here, measurement source value, right? I think that's the field there. And I think the other approach is also creating 2 billion concept IDs, which is a sort of a custom concept ID that you will be using within your organization or organizations. So I'm not entirely familiar with the 2 billion approach, but around the concept ID 0 approach, I'm pretty familiar. But it is not great from a perspective that you can't leverage the source values in a lot of the Atlas within Atlas, right? You need to do custom SQL coding in order to distinguish which of the 0 concept IDs are the ones you're currently looking for. So maybe the 2 billion concept ID approach is a better approach for you at this moment. But I also think you're also in conversation with the OHDSI vocabulary team to get some of these concept IDs that you guys are using to be accepted as part of the OHDSI standardized vocabularies, right, Erwin?
Yeah, but initially, right, we are thinking of including everything, but later we realized that we should not add all the variants like 2 billion or hundred of millions of variants into the vocabulary, because that's going to slow down everything. So what we later refine, right, after the discussion with different parties, then we will focus only on the clinically relevant variants. So it will be the same approach as what have been done in the OMOP when the OHDSI team created the OMOP genomic vocabulary. But because not all of the variants, in the context of our local variants, that probably is not inside the OMOP genome. So we want to.
Sorry, go ahead. Sorry, go ahead.
To add this into the After we add them, right, then only we know that it's working. Then only we will push them to the. Hopefully, it will be added into the. It will be upgraded to the standard concept ID in the OMOP genomic vocabulary. But at the moment, we just want to make sure that it actually works in our local context first.
Yeah.
Does that make sense? Yeah.
Yeah, it makes sense. So right now, the approach you're taking here is to add the non-standard concept so that you can confirm it's a working approach. Later on, if it's feasible from making these standardized, you will be pursuing this with the OHDSI vocabulary team as well to get it as part of the OHDSI standardized vocabularies. Yeah. Thanks for that.
Correct.
Chi has his hand up. Chi, I think you also have some input maybe or feedback you can give us around this. Go ahead.
Yeah. So my question is, the genomic data is from the pregnant women or from the baby?
From the pregnant woman.
Okay, and these are blood specimen?
As far as I understand, it's a peripheral blood. Yeah.
So the variant, you find like over 1,000 variant that matches the OHDSI genomic variant. Is that correct?
Yes.
The OHDSI genomic variant are oncology related.
Yes.
And
yes,
you are finding the pregnant women, the germline mutation variant that has oncology implication. That's I don't quite understand. I don't quite follow that part. Are we saying these pregnant women, they have germline mutation that implies they are going to have cancer? They have oncology related genes? Is that what we are saying, or that's not what we're saying?
I think what we want to show is that how we can actually map them to the OMOP genomic standard vocabulary. But I totally agree with you that the OMOP genomic vocabulary the design is based is the oncology related variants. So that's why from the non-standard genomic vocabulary, we will most likely adding those that are not oncology related variants. Yeah. But this is just a proof of concept. I understand your concern. This is not we are not going to say that all these pregnant women have cancer. Yeah.
Well, yeah. So as long as I know that the current OHDSI OMOP vocabulary for genomics are focusing on the somatic mutation rather than germline mutations.
Yes,
it's kind of
Yeah.
different. But yeah, we may need to expand that vocabulary to include more germline mutations.
Probably there are two vocabulary, like the germline and the somatic mutation vocab. Yeah.
Chi, I don't know if your question was answered, but I do understand your question around how to interpret this, right? So the Singapore team here is getting around 1,000 variants that are matching the current OMOP genomic vocabulary, but those genomic vocabularies are based from the efforts from the oncology work group. So yeah, it's a difficult question. I think it also was brought up in the early discussions with the A-STAR team here, along with the OHDSI vocabulary team. But Yeah, Erwin, I think it's a difficult question to answer. I don't know if you have an answer for us right immediately, but yeah, definitely from an interpretation perspective, it would be great to understand how we can interpret that 1,000 variant matching in the pregnant woman, right? Whether is it really that these people are subject to cancer, or I don't know. I'm not the right person to be making these assumptions, but yeah, it's an interesting topic, right? Okay. The sudden awkward silence is here, but all right. Is there any other? Oh, I see Robert has put in some comments for you in the chat, Erwin. So Robert is saying, if you have any specific set of concepts in mind to expand the measurement type concepts for your specific use case, he's recommending that you put in a ticket in the oncology work group GitHub so that it can be added. So
All
yeah,
right. Thank you.
if you can't see the chat, I'm happy to send this to you separately. Can you see the
Let
chat?
me see. I think if I'm sharing, I cannot see the chat. Probably I just stop sharing first.
Mukesh, can you see the chat? Maybe you can forward it over to Erwin.
Yeah, I do see the
Okay.
chat.
Yeah.
But yeah, that's really very helpful. I think a lot of good discussions today, and these help us move forward together, with the community's inputs. Yeah.
Yeah.
Right.
Thank you for all the input.
If no further questions, Mukesh, I'll hand over to you so that you can close the call.
Thank you. All right. Yeah. So yeah, I think we've shown you a glimpse of the efforts that Singapore is working on. And Chen, we're happy to collaborate closely with you as well. I know that you are also very much keen on the genomic space, on the OHDSI work. We are happy to see how we can make this more as a global effort, for OMOP and OHDSI. And beyond just the genomic data, we're starting to go towards the other omics type that Erwin described. So one of the upcoming ones is transcriptomics. They're starting to look at. So we're starting to see how we can do multi-omics studies on Atlas. I think that's like the end goal that even Christian has, from the OMOP OHDSI perspective. Yep. So let's all work towards that end goal. Otherwise, I think we're good for today. We'll follow up with the next community call in about 2 weeks' time. And in the next scientific forum session, we've actually invited HDR UK team to actually continue on our journey about exploring more ETL tools. So if you recall, last month's scientific forum session, we actually had Perseus tool being showcased. There was a variant of our white rabbit hat tool that we've been using, and now we are introducing HDR UK's Carrot Mapper, which they've developed. It's an open source tool as well, so that will be the agenda for the next scientific forum call. Yeah, so stay tuned for that one. If not, I think we're all good. Thanks everyone for signing in today.
Thank you.
Thanks everyone.
See you.
Thank you.